Hey everyone, it's another Wednesday and I'm here with another shop update. And as you can see, I'm still in the middle of the sliding door project, and let's see what I've been up to for the last week. So on Thursday, I was working on the internals of the sliding door. I was just mounting some supplementary equipment, which will be for holding the lock and for holding the belt and so on. So I was mounting the actual door onto the C channel, so I have it moving, and that was Thursday. And on Friday, I decided to start working on the motor itself because I needed to replace the factory pulley with a bigger one and with a teeth which will fit the belt I bought again. So I have the second belt, which is finally the correct length. And I was like, okay, I have the door moving, I have all the other things, so maybe I can mount the motor, replace the pulley, and do some electric movement tests. So yeah, that was on Friday, and I started with removing the pulley, and well, it didn't work quite as I thought. So let's take a closer look at it. So this is the part of the gearbox, and this is the new pulley, and as you can see that something is missing. And yeah, how did that happen? Well, the first thing I needed to do is to pull the older pulley from the gearbox, and you usually use a sort of a spider mechanism which is able to pull something from axles like bearings and stuff. And I have it somewhere just to show you what I'm talking about. You probably know how it looks like. So this is the spider thingy. I don't know how it's called. And there is a threaded rod inside. There are these movable three legs, and you clamp it like this. And once you are tightening this and it touches the axle, it will start pull the pulley off. But I wasn't able to pull the old pulley off just with this. It was like very fixed. And I decided to start grinding this off, and I will show you the footage here. So it wasn't that hard because all the pulley is made from aluminum, so it's easy to cut. And I sort of measured how thick the axle is, so I knew how deep I could cut. And the plan was to cut it as much as possible, so the pulley will just break off, and I will have the gearbox free of the pulley. But once I was like in a half of the old pulley, the grinder just started spitting out sparks, which meant that I'm starting to hit something other than aluminum, because aluminum doesn't make sparks like this. It just makes dust. So there was actually hidden some sort of a sleeve collar, which was out of metal. So I was like, okay, that's like slowing me down. So I started to cutting more and more, and yeah, I freed up the pulley, and I had to cut it like completely. It just didn't want to come off, and these are the remnants. So here you can see the like inner sleeve. This one's from metal, and it has some inner teeth, outer teeth, and inner teeth. So I really don't understand why it is designed like this. Maybe it's some sort of shock absorbent or something like this. But yeah, pulling the pulley off was quite a feat. So I got that off, and then I decided to mount the new one. And I drilled a hole. I measured the thickness of the axle first, and the inner one was 9.6 millimeters, and with the teeth it was 9.7 millimeters. So the best drill bit I had was 9.5 millimeters. So I drilled that hole and started to press the pulley with my vise, and it went like a halfway in, and then I just felt that it goes smoother and smoother and smoother, and yeah, then I fucked up the vise. So if you can see back here, the vise is actually divided into two parts. This is the movable front jaw, and this threaded pipe should be fixed against the back plate or the bottom section, and the fixing is done with this pin, which should be straight and going through the base plate. So I will show you how it looks on the other side. So it should go inside this hole, and it should be fixed with the pin which will go through all this cast iron body. So I was that strong, or to be more precise, I applied quite a big leverage over this, and yeah, this broke off. So this is another side project, or started to be another side project, so I have to fix this. Unfortunately, the company which makes this, York, which is a Czech company, and they make them for like 100 years, and they decided that this is 7 millimeters in diameter, which is significantly harder to get a hold of, because the other dimensions are like 6 and 8 millimeters. So this is something special, and I'm not sure why is this in this diameter, because maybe it's because it's calculated. With every assembly you are deliberately calculating that if something should fail, that some specific part should fail, and you calculate the strength of this in this way. So if anything should fail, it will be this specific part. So I wanted to replace this with some stronger bolt, like stainless steel A2, but then I realized that I will make this part unnecessarily strong, and that could result in breaking something else, probably this pipe. So I decided, no, I will find the 7 millimeter rod and use this as designed. So that's like a Friday afternoon. I have this broken off, and I still have to had to press the pulley on. So the next best thing I had for this was a hammer, and yeah, this is the result. So I slowly started to hammer in the pulley. So I was hammering on this axle. This axle is metal. I had this nicely supported, so I was like hitting, and then the hammer slipped, and I fucked up the bearing. So that was like a first major disaster, but I realized, okay, it's just a bearing, so I can replace this. It had some markings, so I called a company nearby if they have it in stock. They said yes. I was like, okay, great. So they will close like in 2 hours. I can get there, But first, let me first finish with the pulley. So I started again hitting this thing with the hammer, and yeah, the hammer slipped again, and this time it fucked up the this plastic wheel. So that was like a major fuck up of this project, and I decided that I have to replace it with another gearbox, because trying to guess what type of wheel is this and if I can replace it or anything, that's like something beyond the type constraint I have on this project, and so on. So I contacted the Chinese company which makes these, and I asked for sending me a replacement gearbox, and they said yes. They were very quick, even though it was weakened. And yeah, the replacement thingy is in the mailbox, and yeah, that's end of the Friday story, I guess. So with the motor sort of postponed, I started to focus on other parts of the project, and that was the sheet metal enclosure on the top. So I built a sheet metal bender for that. I have a short video on YouTube and Instagram and everything, and I just took the whole sheet of the metal, started just drawing the shape I need. I thought about this I thought about it for quite some time, so I knew how the bend should go, and how to work around the limits of the bender, because you cannot bend like very short sides, because all the mechanism of the bender is in the way. So I designed it in the way, the box I designed in the way, and the bender I designed in the way that I can make this with the set bender. So yeah, the actual width of the door is slightly above 3 meters. So I split the box into two parts, and I didn't film the first part because I didn't know I didn't know how it will go, and I needed to focus on the process and not on the video making. But the second part I shot on the video. It's again on some YouTube short, and it went quite well. On the first one, I learned how to do certain things, how to bend very small seams, and the second one was much better. And I still had to use a hammer and roofing pliers just to make some smaller and finer bends. But yeah, I think that overall it looks nice. Let's take a look. So this is the whole door, and on top of it is nice enclosure out of white sheet metal. I still kept the foil, which is on the sheet metal from the factory. It prevents the metal from scratching, so I will keep it and just pull it off when it will be mounted on the final location. So this is the one half of the section, and this is the other half of the section. The bend is done very simply. It's like this G channel. It is mounted on the back plates of the top section, and all of it is closed with these sideboards, which are how do they call this? Is it nipple? I'll show the correct name on the screen. So this is the mechanical side of the project, and the enclosure is nicely covering the whole mechanism. And I like how the bends are straight, and there are no no wobbling, and it doesn't vibrate. So I think this part of the project is very nicely done. So that was like Saturday and Sunday. I had a chance to work on the weekend as well, and I think I finished this on Monday, and Tuesday and today I was working on the electronics. So I took the control panel. That's the metal box I showed you in a previous video, and I started mounting all the electronic stuff. So let's take a look at this. So this orange thing, this orange plate is a mounting plate of the enclosure. So you can take this out. It's held in the box with 4 screws, and this is used for mounting all the stuff you need inside of the control panel. So at the top we have a terminal blocks, and this is like the classic topology of things in the control panel, because the control panel is like heart of the project. So all the cables, all the sensors, motors, actuators, every cable is going inside of the control panel, and it has to be terminated somewhere, and that's what these terminal blocks are for, because you have to think about this, that it's typically done by 2 people. One person is making the panel, and another person is mounting this in the final location. And the mounting person doesn't know about the internals, so that's what these terminals are for. The terminals are labeled, so you can have a documentation of what sensor, what actuator, what switch is connected to where. So right here I have the terminals for the mains power supply, mains voltage 230 volts. Here I have terminals for motors and locks, and here are the sensor blocks and switches and encoders and presence sensors and so on. From these terminal blocks there are cables which are labeled to where the cable is going. So for example, the line voltage here goes to a device called F1, and its terminal point 1. So the F1 is the circuit breaker, and this is the terminal number 1. So I know this cable goes over here. This section is for creating a protected mains voltage for the inside of the control panel. So we have the circuit breaker, and we have another set of terminals where this line voltage is behind this circuit breaker, so it is protected, and this is the neutral voltage, neutral line for the mains. That goes inside to the power supplies. There are 2 power supplies. This one is for 24 volts, this one is for 5 and 12 volts. And the low voltages go into this terminal block, so every other device in this control panel, if it needs power, it sucks the power from this terminal block. So that's like the logic. This is for the outside world. This is for the inside 230 volts, and this is the low voltage stuff. And there are other devices, mainly these 2 relays. This one is SSR relay for controlling the speed of the motor, and this is a mechanical relay which is for changing the direction of the motor. And here is the PLC, the programmable logical controller, which is the heart of the automation. This one is from Czech company called Unipy, and it's a model pattern M207, and it features a lot of digital inputs and relay outputs, which are very handy to have for this type of automation. And as you can see, all the cables are labeled, and I'm using a heat shrink which is labeled, and this is pre-labeled by a company, so you can send the list of the labels you want, and they will send you back the heat shrinks. And you can cut them, slide them onto the cable, heat them with the heat gun, and they will shrink and clamp around the wire, so they don't move. I like these ones better than the plastic ones, which are usually are like clear plastic sleeve where you can slide or print and slide some paper, but these ones are quite big, so the heat shrink ones are very small, so they can be used in very confined spaces. And this control panel is done like I don't know, 75% maybe. I have finished with the powering stuff, so I have the 230 volts, I have the low power stuff, and what I'm missing is the control stuff to switch the relays, read the states of the sensors, and so on. So as you can see, there is nothing yet connected to the PLC, and that's what I will be doing tomorrow. So that's the current progress on this project, and tomorrow I will be working on this control panel to get this done, and then I will wire all the sensors and the motor and stuff from the door and move it or connect it to the input terminals, and then I can start playing with how this actually works. So I will be turning the motor up and down, to left and right. I will read the different type of sensors, and just to see that everything is connected hardware-wise in the way that I intended to, and then I can focus on the programming itself. And even though I don't have the motor, well, I still have the original one, which works okay. So I can just have this here and see how this is turning, and I can program the logic in this way. Then, and once the actual motor will arrive, which should be at the beginning of the next week, I will hopefully have everything ready. So I will just mount it and start to like fine-tune the automation and everything. So yeah, that's the current status. So I think it will be slightly interesting for someone who cares to talk about how the motor works, how to actually change the speed and change the direction of the motor. So I have something connected here, but I think that it's outside of the scope of this update. So I will just end this video and this talking here, and I will shoot a separate video about the motor and the controlling of this one. So thank you very much for stopping by, and I'm still posting shorts and YouTube shorts and Instagram reels, and I'm also on TikTok. So if you are into very short updates of what I'm doing, you can try this type of content. And if you think that you are a really big fan of this channel, you can subscribe to my Patreon page. There is no additional content above all of this yet, but you can show me support, which I will reward by writing your name on this wall, and you will be displayed in every video. So thank you very much for considering this. Thank you very much for stopping by, and hopefully see you next week. Bye. And I'm going to shoot the video with the motor now.